The next thing we'll be looking at is the factor theorem, which goes hand in hand with the remainder theorem. But before we discuss what the factor theorem says, I want you to first solve x squared minus 9 equals 0 using factorization. We know that x squared minus 9 is a difference of two squares, x minus 3 and x plus 3. And if I set each of those equal to 0, I'm getting x is positive 3 and x is negative 3, and now I've solved this quadratic equation. And I know that was a very simple step, but I want you to understand that first thing we did was we factored. The next thing we did was we set each of the factors equal to 0, and then we solved. So there was two different things here. We factored, and then we solved. So if I take this information, I can say that x minus 3 and x plus 3 are both factors of the original x squared minus 9. I can also say that 3 and negative 3 are solutions. Or another way of writing that, we could say roots of the equation. Or if we were using function notation, it could be a 0 of the polynomial f of x equals x squared minus 9. Because roots, solutions, and zeros are all very similar. So let's look at the factor theorem. The factor theorem is basically telling you what the factors are versus what the zeros or solutions are. So let's say we have a function f of x, and it's a polynomial and c is a complex number. Then x minus c is said to be a factor of f of x if and only if f of c is equal to 0. Well, we've seen this f of c equals 0 several times. If f of c is equal to 0, then c is a 0, using the definition of a 0. So if c is the 0 of the polynomial, then x minus c is the factor of the polynomial. Conversely, if x minus c is the factor of the polynomial, then c is a 0 of the polynomial. The 0 and the factors are essentially the same information, just written a little bit differently. So if I give you a 0 is c, then you need to know x minus c is its corresponding factor. If I give you the factor x minus c, then you need to know that c would be its corresponding 0. So factors and zeros are different, although they're basically giving you the same information. So on the first problem it says use synthetic division to divide this f of x polynomial by x minus 2. Notice that's written in x minus c form. And then use the result to find all the zeros. Well, if this question is basically telling me that this is a factor of the polynomial. Let's just make sure by using synthetic division. Inside my bar, I'm going to put 2 as my c. Put all the rest of the coefficients. And synthetically divide. 5 times 2 is 10. Add down, you get negative 29. Negative 29 times 2 is negative 58. Add down, you get negative 6. Multiply negative 6 times 2, you get negative 12. Woohoo, I'm getting a 0 remainder. If I have a 0 remainder, the remainder theorem tells me that f of 2 is equal to 0, so therefore 2 is a 0. Yay! So what is the 0? 2. So what is this corresponding factor? X minus 2. These two pieces of information are basically interchangeable. The factor of x minus 2 means that the 0 is 2. The 0 is 2. That means the factor is x minus 2. This is what the factor theorem is telling us. That a factor will tell you it's 0. A 0 will tell you its factor. Now, unfortunately, we haven't finished this answer yet. It says use the result to find all the zeros. Okay, well, I do know that we have f of x is equal to my quotient, which is 5x squared minus 29x minus 6, times the divisor, x minus 2. Great, but I still can't find the zeros of this guy because I haven't finished that. So I'm going to just factor using my factoring skills, because I can factor quadratics, no problem. We've been doing that for quite some time. And this is going to factor into, let's see, 5x and x. And we'll have 6 and 1. So 30 and 1 can be used to make 29, a negative 30x, and a positive 1x. Okay, now this factors completely by 5x plus 1 times x minus 6 times x plus 2. So I have given you the factored polynomial. From here, can you tell me all of the zeros of the function? Well, certainly I know that 2 is a 0 because I've already found that out earlier. But x minus 6 is the factor. That tells me that 6 is a 0. Now, this one's not quite as easy because it's got a coefficient in front, but I can still set that equal to 0 and solve 5x is equal to negative 1, divide both sides by 5, and that looks like negative 1/5. So I still have 3 zeros, which is what I expect because I have a exponent of 3. My highest exponent is 3, so I would expect 3 zeros. So this problem gave me the factor and I found the zeros. The next problem is a little bit backwards. The next problem gives you 1 0. It says find all the zeros of this polynomial given that negative 1 is a 0. So I actually already know what a 0 is. The nearest 0 happens to be negative 1 because it told me so. So I would like to verify this using synthetic division. So the negative 1 is the 0 that goes inside the box. Using synthetic division, I drop the 15. 15 times negative 1 is negative 15. Add, you get negative 1. Negative 1 times negative 1 is positive 1. Add down, you get negative 2. Negative 2 times negative 1 is positive 2. Add down, you get 0. So this is f of negative 1 happens to be 0. Yay! We have a remainder of 0, so the remainder theorem tells you that f of negative 1 is equal to 0. Therefore, negative 1 is a 0, and we have verified that negative 1 is a 0. That tells us that x plus 1 is a factor. You use the opposite sign here. The 0 and the factor always have to have opposite signs. So I know that f of x is equal to x plus 1 times the quotient, and the quotient would be 15x squared, the quotient's found here, minus 1x minus 2. Well, I know one of the zeros is negative 1, but I don't know the rest of the zeros. I'm going to have to factor. Because my quotient is a quadratic, I can just factor using the skills that I've learned in the past. We'll try 3 and 5. I'm using guess and check. You can use any factoring method that you want. Try 2 and 1. 6 and a 5. We'll put a positive 5 and a negative 6. And now I've completely factored f of x into 3 factors. So all of the zeros are going to be negative 1. If I set this equal to 0, I'm getting negative 1/3. And I set the last factor equal to 0, I'm getting positive 2/5. So it doesn't matter if they give me a factor. I can find the 0 and then find the rest of the zeros, or they could give me 1 0 and I could synthetically divide and find all the factors and all the zeros. One more problem, we're going to be using multiplicity. I want to find all the zeros of this polynomial given that 1 is a 0, but it's a 0 with multiplicity 3. So I'm going to verify that 1 is a 0. Multiply down, I get 4 times 1 is 4. Add down, you get negative 5. 1 times negative 5 is negative 5. Add down, you get negative 2. Multiply, you get negative 2. Add down, you get 3. Multiply 3 times 1 is positive 3. Woohoo! 1 is a 0. So I can rewrite f of x is equal to x minus 1. That's my factor. If 1 is a 0, then x minus 1 is a factor, times the remaining quotient. I started off to be x to the 4th, so now I'm going to be 4x cubed minus 5x squared minus 2x plus 3. But you know what? I can't factor this cubic. I don't know how to factor cubics. It did tell me that 1 is a 0 with multiplicity 3. So I'm going to take the remaining quotient here without the remainder. I'm going to take out the remainder and try to synthetically divide it again using another 1, because I know that 1 is a 0 with multiplicity 3, so it should work 3 times. So let's go ahead and see if this works. 4 times 1 is 4, add down. -1, add down. Multiply, and -3. Look at that, I got another 0, which tells me f of x is equal to x minus 1 from the factor before, times another x minus 1 from the factorization we just did, times the remaining quotient, which is 4x squared. It was cubed, now it's down to squared, minus 1x minus 3. But I'm going to go ahead and do it one more time because I have a multiplicity of 3. So I'm going to grab another color, and I'm just going to do the division one more time, take out the remainder, and just do synthetic division with the quotient. 4 times 1 is 4, add down, you get 3. 3 times 1 is 3, add down. Well, look at that, you got another 0. So therefore my polynomial is f of x is equal to x minus 1 from the first one, x minus 1 from the second one, plus from the third division we have another x minus 1, times the quotient 4x plus 3. So this is my factored polynomial. I could rewrite it instead of x minus 1 times x minus 1 times x minus 1, I could rewrite it just x minus 1 cubed. And now I'd like you to tell me all of the zeros. Well, we have 1 being a 0 with multiplicity of 3, although they kind of gave you that information, didn't they? And I have one more 0 coming from the last one. If I set this equal to 0 and solve, I get 4x is equal to -3, or -3/4. Remember we said that a polynomial of degree 4 should have 4 total zeros. Do I? 1, 2, 3 zeros are all -1, and the fourth one is -3/4. I do have all 4 zeros. The last thing that we're going to be doing is finding polynomials if I give you the zeros. I want you to find a polynomial function of degree 4 with the following zeros: -4, -1, 0, and 2. Notice I gave you all of the zeros, and all you have to do is find a polynomial function. This may not be the only polynomial function, but you're just going to find one. If I know -4 is a 0, then that tells me that x plus 4 is a factor. If I know -1 is a 0, then x plus 1 also has to be a factor. If 0 is a 0, then the factor is going to be x minus 0, and then the last one, if 2 is a factor, then x minus 2 is a factor. You could distribute this out, but I'm going to ask you to go ahead and not distribute it out. Just leave it like this. The only thing I might make a little more simple is no one writes x minus 0, do we? We would prefer just to write x, and usually we'll write that in the front. If it's just a monomial, we put the binomials in the back. So this is probably the best way of writing it. But please don't spend your time distributing it out. On the next problem, it says find a polynomial function of degree 3 with zeros, and they give you the 3 zeros. I want you to understand that there's more than one answer here. If I have a 0 of 3/4, then my factor is going to be x minus 3/4, is one of the possible factors. But can you think of another factor for a 0 of 3/4? And usually some clever student comes up with the idea that if we had a factor of 4x minus 3, well, that's also going to get you a 0 of positive 3/4. Notice that the two factors that we came up with that both work are really only multiples of each other. If I take this first one that I found and multiply it by 4, I'm going to get the second one. Notice I didn't ask you to find the only polynomial function, I asked you to find a polynomial function. So there could be more than one answer as long as each of the zeros are covered and that you only have a degree of 3, meaning you're only going to have 3 x's, or 3 factors. The next one, I have a 0 of -1/2, so I could write that x plus 1/2, or I could write 2x plus 1. Notice the signs are opposite in both of them. And the last one, everyone probably is going to agree with x minus 5 being the most simple factor for a 0 of 5. Either of these are both acceptable. I wouldn't necessarily make you put both of them, but if I asked for a polynomial function, you could give me the first one, and your neighbor could give me a second one, and you're both going to get it correct. This last one is basically the same, except I'm giving you a multiplicity of 2. So we have a degree of 3, so I have 3 x's that I'll be using. I have zeros of 5, but the 0 of 5 has a multiplicity of 2, so I have x minus 5 times x minus 5. Both of those are factors. And I have a 0 of negative 8. That gives me an x plus 8. And if you multiply all these three together, you get a degree of 3 with the following zeros. The only thing that might make it a little bit nicer is instead of writing x minus 5 times x minus 5, we could just write x minus 5 squared, and that's just a little bit more concise. So in this section, we covered how to synthetically divide. We used the remainder theorem to evaluate at a value c. We talked about zeros of a polynomial, and we used the zero definition in the remainder theorem to find out if a c was a zero. And lastly, we talked about the factor theorem, that if you know that c is a zero, then x minus c must be a factor, and vice versa. If x minus c is a factor, then c must be a zero.